So hello everyone. This new chapter will deal with something that we call energetics. But basically what it means is that we will explore how cells do their work and how they function. So in order to do this, I need to explain in just a few words what the concept of energy is. So the concept of energy is defined as the capacity to do some work or to make sure that there is change. So for example, if we look at this picture right here, we see that we have a controlled explosion of a smokestack. So on your left, we see the smokestack over there, the first one being almost intact. And then as the explosive charges are set off, we see that there is bulging right above the middle of the smokestack. And then eventually the smokestack, the structure, falls down. So this structure was standing there, but it was standing and it had a certain amount of energy to it. And as we cause change in that structure, then the energy changes as well. So nobody in their right mind would be standing anywhere near the bottom of this structure as it starts to crumble down and fall in pieces. And the reason for that is that we know that all the bricks and whatever is used in this construction will fall down with a certain velocity and of course will hurt you, if not kill you. We also know that as the structure comes down, it will displace the ground around it. And this displacement of the ground, this change, is something that we call work. So we know that work is change. But the thing is that in order to induce this change, we need something that we call energy. So when we look at the kinds of energy we have, we know that there are two types of energy, and one is called kinetic energy. So if I compare this with the previous slide, the falling of the structure, we know that the bricks as they crumble, as they get displaced from one another, will fall to the ground and will be attracted by gravity, and it will gain speed as they come down, right? So the movement of objects that we've seen in this slide is what we call kinetic energy. Heat is another kind of kinetic energy. So say that you put your hand on a stove, on the element that's turned off, then you can touch it. But at some point, if you turn on the element, you start to feel some kind of heat, and hopefully you'll be able to remove your hand before it becomes really hot. And why is heat kinetic energy? Well, it's because as the element gets warmer and warmer, the reason why it gets warmer is because the molecules that are making this element, so they're part of the compound of the element that's getting warmer, these molecules are moving faster and faster and faster. Now, when you think of electricity, that's another type of kinetic energy. So say that your cell phone has only 1 bar left of battery. You know that eventually your cell phone is going to shut down. And the reason for this is that at the moment when you have no more electrons flowing in the circuits of your phone, the phone will turn off. So the circulation and motion of electrons through the circuit boards of your cell phone is another kind of kinetic energy. light also has kinetic energy because we know that light has speed. So light has movement as well. So all of these here are examples of kinetic energy. The other kind of energy is known as potential energy. And this energy is stored. It's not necessarily available at any given moment. It is energy that an object has because of its location or structure. So again, let's think of the previous example. We know that what we have here is structurally sound, right? It remains in place and probably remain there for years and years and years. We know that if we provoke the disintegration of this structure, it will crumble as pictured right here. So this structure here, because of its structure, had some kind of potential energy. And because there is movement throughout this destruction, there is a change from potential energy to kinetic energy. So we see that the energy right here, which is high in potential energy right here, gets eventually transformed into kinetic energy. So this one here has no kinetic energy whatsoever and then gains full kinetic energy here, but at this point has no potential energy. So potential energy is stored energy, and that's important to remember that. Now, when we think of potential energy and we're thinking about cells, we need to think about chemical energy. Because, of course, our cells are made of molecules, and molecules are chemicals. They are held together by chemical bonds. And those chemical bonds, whether they are polar, covalent polar, or covalent nonpolar, they will harvest potential energy. Now, if you think of the battery, right? So I was talking about, I was mentioning the cell phone earlier. So, for example, when you are charging your phone, the phone might be off. But what we do is when we charge our phones and our devices, we store energy. We store energy, and the energy will accumulate in a battery. So basically, when a battery is dead, it has no potential energy because all potential energy has been converted into kinetic energy. But this kinetic energy is shown as a device that works, and at some point the kinetic energy will disappear as well. So in order to gain more kinetic energy and have a device that's functional again, we need to boost this potential energy by charging the phone. So to demonstrate that potential energy can be converted into kinetic energy, I am showing you this picture of a diver. So I think most of you have tried this before. We climb a ladder and then we stand on that diving board. And, sometimes we wait there for long minutes deciding if we want to do this or not. But when we decide to jump in the water, there is a point where we are at the greatest potential energy we will get. We have stored energy. Why is that? Well, because the difference in height between this here at water level and the diving board right here, this height, the difference means that we have a certain amount of energy. So we have stored energy. And we know that by experience, we know that if we jump from a certain height, we will fall down. And as we fall down, we know that we will get faster and faster and faster until we touch down the water. Now, if your diving result will be a 1.2, 8.8, or 10, doesn't matter here. What happens is that this potential energy, which is quite high right here, will be, when you touch water, will be equal to 0. But your kinetic energy here, as you wonder if you are going to jump or not, is at 0 at this point. But when you touch water, this kinetic energy will now be high. So you see that the potential energy is now converted into kinetic energy. Now, if you want to do this again, you can. What you'll do is you'll get onto that scale again, and then you'll go up the ladder and then go up on the diving board again and jump again, right? So kinetic energy will be transformed into potential energy again, and so on and so forth. So machines and organisms can transform kinetic energy to potential energy, and the potential energy can be converted into kinetic energy. So we know that. What I want you to understand here is that the total amount of the energy of a system, so the total amount of a system, so let's draw a box here, and let's say that I have a certain amount of energy in here, and this amount is undisclosed. I'm not sure how much energy there is in here. But when we convert this energy into whatever we have here, if we convert it into kinetic energy or potential energy, and if we do both of them, say that we convert this amount of energy right here into those two types of energy, well, in this case here, if we add up the amount of kinetic energy plus the amount of potential energy, it will always equal what is found in E. So basically, this is the principle of conservation of energy. Energy can be converted from one type to another type. Energy cannot be created out of the ether. We don't destroy energy. Energy is. And energy is always conserved. Now, because I want to relate this part of energetics to what our cells can do, I want to illustrate and to tell you that organic compounds. So what are organic compounds, right? So organic compounds are molecules that have in them carbon, hydrogen, oxygen, and then also other types of atoms, but mostly carbon. So if you remember well, organic chemistry is the chemistry of carbon compounds. So when we're talking about organic compounds, we're talking about all the chemicals that our cells are using, making, etc. There's a few exceptions, but for the most part, those are all organic compounds. Well, guess what? Those organic compounds are usually rich in chemical energy. So for example, think of glucose, right? Glucose or any kind of sugar. We know that glucose has a high amount of energy. When we are in a certain state, so say that you've been doing some heavy exercise and you haven't eaten for a while, well, you know that at some point you will feel that. You'll be low. We say that we are low in blood sugar. Well, blood sugar is, for the most part, glucose, and glucose gives us energy. So in order to gain your energy level back, and you will feel that, you will have a meal, you will have an energy drink, you will have some kind of nutrients that will top up your energy levels. So where is this energy coming from? Well, we define this, as I mentioned before, as chemical energy. And the chemical energy arises from the arrangement of the atoms and also their electrons. And keep that in mind, because at some point when we talk about cellular respiration, we will talk about electrons quite a bit. And those electrons play a huge role in the energy that our cells can extract. Right? So the chemical energy arises from the arrangement of atoms and their electrons. But the interesting thing here is that this energy can also be released by a chemical reaction. So say, for example, that we have A plus B, right? So we have two molecules that can react together, and this will give us an organic compound that we call C. It is possible that when A and B react together, there is a release of energy. So for example, if you dissolve a certain compound in water, when you touch the beaker after, it is possible that this beaker will become warmer. And why is it warmer? Well, because it releases some kind of energy. It is also possible that A and B, as they react to form compound C, it is also possible that it will consume energy. In this case, you would touch the beaker and you would feel that this beaker becomes cooler as the reaction takes place.